quite a few impressive mini-engines have come out in the last couple of years. The INN engine is one of them, and it's a very unique design with huge potential benefits. It is an opposed multiple-cylinder engine with a unique cam track. It is considered to be a one-stroke without the fuel-oil mixture of a two. With no crankshaft, valves, or even a camshaft, it is 70% lighter than a comparable four-stroke. So it can achieve the emission standards of a 4 with the lightweight benefits of a 2. But is it truly a game changer? And is it truly a flawless design? The opposed piston engine has been around since the 19th century, and it's a fairly straightforward design. Just like the INN, there are no valves, cams, or camshafts. But these predecessors were a little bit different because they featured a dual crankshaft with more complex synchronous gearing. One of the more infamous variants came out in the 1930s, and it's called the Junkers Jumo 205. It was light enough to be featured in multiple aircraft, and over 900 of these engines were produced during this time. The two-stroke 12-piston could produce over 600 horsepower, but this was quickly displaced by newer radials and even jet engines. However, the Napier Deltic took this idea even further with an 18-cylinder Delta configuration, and was initially featured in naval craft and then eventually ported over to larger locomotives. It topped out at 1600 horsepower, but it was a little bit tricky to work on, and more efficient diesels quickly displaced the Napier Deltic. Several decades later, Achates Power resurrected the simpler opposed piston engine design. This is still considered to be a pretty risky play because it is believed that two-strokes will not be able to meet emission standards. Not to mention, it's going to compete against newer electric vehicles. But like many new engines out there, Achates utilized computational fluid dynamics to increase efficiency. By iterating the design in simulation, engineers understand how parameters affect key failure modes. Temperatures can be measured on the piston crown, and problems can be pinpointed before prototyping. One of their frontrunners is a 10-liter, 400 horsepower, 1,600 pounds of torque model. More importantly, it reduces emissions enough for Class 8 trucks, and this is even good enough for EPA requirements. It is also a very good market to target because there still is a lack of charging infrastructure and limited range for large electrical trucks. So an OP engine could be here to stay this time. Walmart is already testing this new Achates opposed piston, and there are already plans to replace heavier 13 and 15-liter engines. So there is legitimacy behind the design. But it's going to come down to the true actual emission numbers, and really if it can overcome previous opposed piston deficiencies. One of the more interesting questions is whether or not this can translate into lighter applications. And the INN is a parallel development which would effectively be a range extender. It would be able to reduce the number of batteries used, increase range, and add flexibility to charging. So this can be used in a lot of different things, including electric VTOLs. However, this company's taken a little bit of a different approach because this variant is actually utilizing a 3D cam track configuration. Built out of a proprietary temper steel, we are probably looking at the most critical component of this design. It's not necessarily a completely new idea because we have seen steam engines in the past with track rail guides. But making a 100 horsepower prototype is definitely pushing the boundaries of materials and machining. The company is also prototyping a simpler straight 125 with the same cam track system. The 125cc 22 horsepower engine should be available at the end of this year. So like many of you out there, I'm a little bit skeptical of the INN, but I like the design. It's going to show us whether or not a cam track system will even work. And on the flip side, we have the Achates Power engine, which has already proved that a two-stroke can meet current EPA demands. So the one thing to keep in mind about these opposed piston engines is that they were there to replace the battery at some sort of magnitude. And the thing is I think that's a really good idea because for one, in the INN, we can use less batteries, so that means less materials that are sourced from cobalt and nickel and things like that, which are very, very scarce right now. And another thing too is that the Tesla semi-truck, as much as I like it, is very heavy duty on battery packs. It's over 850 kilowatt hours. And to charge something like that would take over 45 minutes to only get 500 miles. And as some of you know, with a Class 8 truck, that's not very good at all. So having said all that, I still think that we will eventually have 100% electric vehicles on the road. But it's going to take time because we need advancements in battery energy densities and power generation, which can subsidize the grid. And by that time, I think that this will be possible, but that is still a decade or maybe even more than that away. One thing's for sure, it's very interesting to see the opposed piston being resurrected and refined to a point where it can be practical and meet emission standards. With the ability to run on hydrogen, this also makes it a very interesting dynamic as well. But we are living in very strange times, and maybe all of this will be superseded by AI innovation. More importantly, I would like to know what you think about all this. So please leave a comment, like the video if you enjoyed it, and also make sure to subscribe to my channel.